Hello, everybody. This is a short recording to just clarify something that I noticed while revising the recording of the last lecture when I was explaining the electromechanical relay. I discovered that in my mind that I flipped the pins. So I thought just to make this short recording to show you how we can use the electromechanical relay. And I'm talking, we were looking at this relay that I shared its data sheet with you last time. And I was talking about connecting the controls here and the thing that we're going to control over here, but it is the opposite. So I looked for a better top view of the relay to see the pin layout better. So if we are to use this relay, and we said we use relays to isolate between the power of the microcontroller and the power of the thing that is to be controlled. We said in principle the relay is a electromechanical. There is a metal piece over here that can be switched between normally closed or normally open if voltage is applied to this inductor that will cause an electromagnetic field, and that will pull this switch down or leave it to go up. Okay, so it is mechanical. The purpose is to switch things on and off, not to do really fast switching. So like PWM, you cannot use this for a PWM because switching will take time. To do PWM or fast switching, you'll need a solid state relay. Let's do this example. If I am to control the 220 volt light bulb, okay, to turn on and off, on or off the light. Here, of course, the 220 volts AC cannot be provided by the microcontroller, so it's going to be external. If from the home or house power source, so we get to use the relay and control it through the microcontroller. So if I have my microcontroller unit over here, let's say we're using the HCS12 microcontroller unit. The microcontroller, of course, you need to power it and connect its ground, and we'll use a port to control the appliance that we want. Let's say port B0. To do this, we bring the light. We connect the light this way. Sorry, this is the light, right? The light socket has two lines, right? And we need to, this is the power outlet, 220 volt power outlet. Okay. Let me use colors here. If the color, so this is the, let's say the neutral, and this is the power source. So I connect well, this is the neutral. So the black will be the neutral. I connect it directly. I take the other line, the hot line, the red. I'll use red color. Okay. And I want to use the relay over here, this one. This one, let me pull it down and make a smaller version of it, put it over here. Okay. Let me just Okay, let me do this. Can I take a screen or a snapshot, a screen clip? Oops, sorry. Escape, escape, escape. What I want to do is I drew this thing close. Let me just make this a little smaller and put it over here. Okay. So the way to control this is that we get the 5-volt VCC connected to the power controller VCC. The ground we connect it with the power controller ground, and the signal, I'll draw it in blue, for example. The signal I connect it to the pin, the parallel port pin, which is in this case, port B0. So we write a 1 or a 0 to control on and off. Now this switch, we either connect, we take the line here to, again, colors. I take this to the common pin and take the other pin either from normally closed or normally open. So let's choose normally open and see what happens. Normally open and connect it to the hotline from the power outlet. So in this case, we will have a switch like this. Okay, that would close. When we write a 1 over here. Okay, you write a 1. This switch is normally open, so the light is off. When you write a 1, the switch will close, and we will have this circuit will close, and current will flow, and the light will turn on. Okay, this is one configuration. The other configuration is, I'm going to erase this. The other configuration is that we take this to normal to common, and we take this to normally close. Okay, so normally the switch is closed here, so the light is always on when 0 is here. Oh, it's always on. When I write a 1, the actuator, the magnet, the electric magnet, will pull the switch out and cause an open circuit, resulting in turning off the light. I hope this explained the thing and corrected any misunderstanding from last time. Thank you very much, and see you in class next time.